All right. So we'll kind of pick up where we left off for some housekeeping stuff just to get out of the way. I'll repost this after class today because it kind of changed this week. Group 1, you guys meet Monday, Friday. Group 2, kind of on Wednesday. Based off of Friday and today, we've got a ton of extra receipts. So if you want to show up in person, I'll have these groups that kind of give priority, but looks like probably gonna be able to get in most days that you want to, if you want to attend in person. So, so that gets rid of that. I posted on Friday the first Connect homework. It'll be due 2 weeks. I could have waited and posted it today, but I figured if someone wanted to take a look at it this weekend or kind of at some point on Friday, they could have. So it's 13 questions. After today, you'll probably answer, I think you'll be able to get through 12 of them. So there's be still one that we have to cover some extra material on Wednesday. So I would start working on that so that the material doesn't get too far removed from your mind. But I know got other class and things, so we still have quite a bit of time until this is due. Really next Friday at the end of the day. So you got a lot of time to work on this. Get started on it early. Ask me questions if you have them. Okay. After class today, I'll post the first Excel assignment. So you kind of have two concurrent assignments. So I get as much done on those as you can as early as possible. Okay, so I'll pull open last week's slides just to kind of remind us of something, okay? So here was that equation we were using for the population variance, all right? We said we're gonna go through every single observation. We're gonna take the value, subtract the mean, square that deviation. Once we do that for every single observation, we're gonna add them all up. And then the final step was we have that divide by n or divide by the total number of observations there, right? For a sample data set, we said the only difference was instead of dividing by the total number of observations, we divide by total number of observations minus one, right? That was the only difference between the population and the sample. So we worked through some problems. What I wanted to show you today, so I actually get to this week's kind of lecture slides, is, so I showed this in terms of a sample variance. The same thing would be true for the population variance. But we can actually rewrite that variance equation in this form. Okay? So here, the sum of the x's squared means go through every single observation, square it. Once you do that, add them all up, and then subtract the number of observations times the mean squared. So this equation will actually give you the exact same thing as the equation we talked about on last Friday. Now, I showed you this one for a reason. A, when we do some stuff with weighted variances, it's way easier to just manipulate this equation a little bit, which we'll go through today. But also, we said a good way to think about the variance is really like this average deviation from the mean of the observations. Well, you can't really see that from this formula, right? It doesn't necessarily reflect that as well, okay? Well, this formula kind of did, right? We were kind of taking the average of these deviations, right? We measured the deviation for every observation and then took the average of them, essentially, okay? So whenever I tell you something, I don't want you to believe me, these two equations are the same, you can get there through this mathematical proof. I don't expect you guys to know this, reproduce this, or completely understand it. We're not even going to walk through it completely. There's some pretty cool stuff here where they multiply by 1, so n over n is 1, and then it gives them enough to rearrange and eventually get down to this formula. Now, this originated because if we're doing this by hand, this could potentially be a little bit easier to deal with. But we'll kind of see that with Excel, it really doesn't matter. We can do either way in Excel pretty easily, right? Even if we don't want to use a built-in function, okay? So we had that football salaries data set. So one way we can see this applied, right, is with that football salaries data set. So the first thing we're going to do is go through every single observation and just square it, write that number down. So the first thing we needed was take all those values, every observation squared, add them all up. So that's how I got this 328,000 down here. Okay. My mean, if we remember, was 134.5 or 0.51, I guess. So my mean squared, I could just put that in my calculator, square it. Now here's that new formula, now I've got the sum of my x's squared. The number of observations I have is 10, and I have that mean squared calculated as well. Plug those values in. The only thing I'm forgetting to do is, go back here, we said, right, divide by n minus 1 for a sample, or divide by n for a population. Well, that's the same as multiplying by 1 over n minus 1, or 1 over n. So here we were treating this as population data last class. So once we get down to this point, we still have to divide by the total number of observations, and we get the exact same thing as we did using this formula last class. Okay? So it doesn't matter which method we use, we'll kind of reproduce the same answer. Okay? And I think we went through this last class, right, where we said different means will shift the distributions, and if they have higher variances, that kind of flattens them. So we went through that. And then we kind of had this summary of these different formulas that were measures of central tendency and measures of dispersion. Okay? So it's kind of a nice summary for Excel. So we'll pick up here on weighted means, but I want to show you some stuff in Excel for a second. So, oh, why did I stop? I'm sharing my screen. I wanted to just exit out of this. There we go. So I'm just going to pull open this COVID data blank file, right, that we've been working from, and use this last worksheet, which is the U.S. unemployment. So it doesn't matter what data we used here. So we'll use this unemployment rate variable. So first I'm going to go through kind of the old way, right? So old way, we wanted to take every observation, subtract the mean, right? And then square that value, right? I'm going to write squared as caret 2 because we'll see that once we do this in Excel, right? So in Excel, take the very first observation, subtract the mean. Now I don't have the mean in the cell. I'm going to put it up here in just a second. Okay, so I'm going to select G1 here, and I'm going to calculate the mean there in just a second. To square something, we just use that caret, so what, shift and 6, right? And then whatever power we want to raise it to, here we just want to square it, so to the second power. Okay. Now, over in here, on F1, I'm going to put, oops, I hit my caps lock. How do we calculate the mean last class? We said we just use that average function. We go over to that very first cell, Control Shift or Command Shift on a Mac, hit the down arrow, we've got our mean. Okay? Now that's great, but when I copy this down, because I want to do this for every observation, I don't want to keep typing it in. So what do I need to do here? I want B2, when I copy this down, to become B3, but G1, I want to stay as G1. Right? So what can I use to freeze that reference? Say, hopefully we're getting this now. I think it went over it a bit. Now, a nice little handy trick to do this. See when and actually I'm going to zoom in a little bit more on this. See when I'm over this, there's this like little green square down here. When my mouse goes over it, my cursor becomes this like plus sign. If I double left click on that, it basically copies it down so I don't have to drag it. Now with a small data set, that doesn't save me a ton of time. With a much larger data set, that's really, really useful. So I've now got the deviation from the mean squared for every single observation. So I'm then going to add up all these deviations from the mean squared. In Excel, what function can I use to do that? Remember that one? Just sum, right? Basically, sum up and then just select your values. Right? Move this out of the way. So we add up all those values. That should be the numerator for that variance equation we had last class. The last step, divide by the total number of observations, okay? So here's where I'm going to show you something. You don't have to do it this way. You could calculate your total number of observations in a different cell. But one nice thing about Excel is we can do everything in the same cell. So here's my numerator, right? And I wanted to divide it by the number of observations. So the one way we said we could count the number of observations in Excel was to use that count function. All you have to do is select the cells, and it counts if it has any value there. So we'll highlight our original variable. What that count function should return to us is just the total number of observations. Okay. Now we're treating this like population data. If it was sample data, the only difference I would have to do here is subtract 1. Okay. But we're going to treat this as population data. Sure enough, I get a variance. Okay. let's make sure that we're doing this correct. Right? So last class we said we can use the var dot, and we're using a population data, so var dot p. So hopefully, when I select this variable for var dot p, hopefully it returns to me the same value that I came up with. Sure enough, it does. Okay, so that's good, right? So that was kind of how we talked about it last class. The other way we could do it, and here I'm going to leave a column in between, is say let's just take, I can just write it, I don't have to put it in parentheses. Let's just square every single value, right? So take this value, square it, right? I can then copy that down. Now I'll kind of show you my shortcut has a flaw, I think. If I double left click, notice if it's not like next to the rest of my data, it won't copy it down for me. So that kind of, leaving that column in between kind of gives me a little more work, but I'm doing it because I want to add some labels. So with a small data set like this, it's not too bad for me to copy that down just by hand. So now I have every single observation squared, right? So sum of the x's squared, right? I want to add these up. So I'll go add up all these, sum of the x's squared. We then look at that equation somewhere back here. I said take the sum of the x's squared and subtract the number of observations times the mean squared. Okay? So I'm going to take this value and subtract the number of observations. Well, I didn't have that. We said we could use that count function to get that. So count up the number of observations. And then multiply by, well, I had the mean up here. So I select the mean, puts that cell reference in there for me, squared. Now the very last thing we also needed to do was still divide by the total number of observations, right? No matter which way we use, this is going to give me my numerator, but I still need to divide by the total number of observations. So I could actually just use that count function again. Instead of selecting it, this is just what I do. Whenever I know the cell reference and I've already have it in here, just B2 through B17. I just type it in because I can see it right there. Okay. This should, if I'm not lying to you, return to us the exact same value we have over here. Sure enough, we get the same thing. All right, so just different ways of calculating the same statistic. Now, if you want to get good in Excel and feel really comfortable and you know the formulas, like obviously this is probably the easiest way to do it, but doing the behind the scenes kind of can prove to us that both those ways would work. Yeah, so just kind of different ways of looking at the same thing there, and just kind of looking at Excel again for today. Okay. Any questions over any of that? It's not too bad. Okay. All right, where were we? So we did this stuff. So we'll start talking about some weighted means. I'm going to switch from some of the examples in the slides. I don't like them today. I have a different example I like. So let's say, so I'll show you why this is true in a second. But when we calculate a mean, essentially what we're doing is we're allowing every single observation to have the same influence over that mean, or they all carry the same weight. They represent one company, one person, one, whatever. The problem is, what if we don't want to do that? So what if we have data where a certain value doesn't just represent one person? So the example I'll give you is, let's say we have instead of states, I'll do countries, right? So let's say we want to calculate the average life expectancy in the world, okay? Well, if you go out and try to find data on this, to truly calculate the average life expectancy, you would need how long every single person has lived that's died, right? You would need like every single death, right? And the year they died, or their age they died, I should say. That seems unreasonable. A lot of countries try to calculate that on their own. So like you can go out and find the life expectancy in Russia, the life expectancy in the United States. So that's probably the only data I have. So if I'm looking at the life expectancy from every single country, that's essentially group data. I have one statistic. I see that, in the US, it's, 79, whatever it ends up being. But that represents more than just one person. That represents every person in the United States. So when I'm calculating this average, well, if I look at the life expectancy in, China, do I want that to be having the same weight as the life expectancy in, I don't know, Taiwan? A much, much smaller, right? No, I mean, the life expectancy for Taiwan represents way smaller number of people than that life expectancy value for China, right? I think the example I had in here was, what if we were looking at like group data for sales, but some companies have a lot more locations than others? Well, we have to take that into account, okay? So instead of just taking the mean across every country for those life expectancies, I want to weight them somehow, right? Because it's group data. I can't actually see each individual death. So what we'll do is use this formula. All right, now, more often than not, a lot of the examples that we'll look at today, but I'll show you a couple where it's not this, the weights usually represent number of people, right? Or the number of companies that observation represents. So you'll go through, and now we have group data, right? So we'll see this grouped by country. So for each country, in my example, I would go through, take their life expectancy, multiply it by the population, or whatever we're using as our weights, or maybe the number of people who have died in that country, okay? Once I do that for every country, I would add them all up and then divide by the sum of my weights there. My weights being the number of people that died, I would use kind of add all those up and use that as my weight. And I'll show you why this makes sense here in just a second, but I want to go through the next slide as well. So here's basically in words what I just said. Multiply each value or each group's value by its weight, then add up all those products, right? When you multiply the value by the weight, that's a product. So add those all up, then add all the weights up together so that you can have your denominator, then divide the sum of the value times the weight by the sum of the weights. Right? That's just kind of in words what we're doing. Okay? And we'll go through some examples, but I want to kind of give you I want to compare this to what we were doing before. So, and whenever I switch this stuff, if you guys, I should be writing stuff down here in just a second. So if you can't see that on Zoom, let me know. It was working earlier, so hopefully it'll keep working. The light's on, but it's still not very bright. So let me see it. If you need clarification or anything, let me know, okay? So what we were doing before, that was our mean equation, right? We could break this down and rewrite it this way, right? We're just adding up every single value, dividing by the total number of observations, okay? I'm going to rewrite it another way. Okay? I'm just going to take that n and kind of, right, everything's getting divided by it, so I can write it like this as well, okay? Do one more thing. I can actually, dividing by n is the same as multiplying by 1 over n. So I can actually pull that 1 over n out in front of every observation. So here, the old way, when we had non-group data to calculate the mean, let me try to get this straight. Everything's getting weighted by the same amount, 1 over, it was 1 out of total number of observations, okay? So before, we were essentially weighting everything the same, okay? Let's go through a slightly different example, right? Let's say that I've got 2 groups. Maybe I'm interested in something like, I mean, just so these numbers kind of make sense. Maybe I've got like 2 classes. I'm wondering what the average grade across my classes are. But each class, I can only see what the average was. So like maybe, I don't know, the average in one class was a 75. Think about grade here. The average in the other class was, I don't know, 70. Okay. Well, let's make this interesting. Let's do this instead. Okay. However, this class that got an average of 80, maybe I only had 10 students. And this one, maybe I had something like 50. Right? So I don't want to simply take the average of these 2 grades and say that the average grade across my 2 classes was a 75, because this average of a 70 represents way more students. If this was the average, then there's going to be way more students who get D's in this class than there are in this class, right? So I can't simply treat these with equal weight. So what I would go ahead and do is take that variable I'm interested in, multiply by the weight. So I'll write this out. So 10 times 80. Add to that the next group, 50 times 70. And then divide by the sum of my weights here. So 10 plus 50. Okay. So another way to think about this is, how many total students do I have across these two observations, right? There are two classes, 60 students, right? So really this first one should represent 10 out of 60 students. Well, notice here's my equation to calculate the weighted mean. If I just rearrange this a little bit, so I add these up and say, this is actually 10 over 60 times 80, and this is 50 out of 60 times 7. Right? That's just me rearranging this. So really what we're doing with that weighted mean equation is saying, well, look, take that value, but what proportion of the total does that value represent? Well, it's just 10 out of 60. So these are kind of like our weights that we're really using. It's just when we calculate it, we don't exactly see that, right? But this is a good way to think about it. And I'll come back to another example like this if we have time at the end that really highlights this. But this is a good way to think about it, right? This observation, this one class represents 10 out of 60 students. Now, I can't see each individual student's grades, but I can see kind of the average grade in the class, okay? Any questions on that? Also, if this ever gets too crooked, let me know, because I'm kind of doing it on an angle and trying to look at it on my screen and make sure it's not like looking like something like this. But if it ever gets too crooked, let me know. All right? We're good with that? Okay. So in this scenario, which one of these grades should influence that weighted mean more? The one that kind of has a higher number of observations or has a higher weight. I shouldn't say higher observations, higher weight here, okay? All right, so let's go back. Brief pause here as the screen catches up to us here in person. Sometime today, maybe? No? I might have to stop share. I wonder if that's why it doesn't like it. There we go. All right. So we've got this equation. Let's look at some actual observations, some actual data sets. So you can go out to the Census Bureau and you can get, they have a huge sample of people, and you can get income reported to you by different characteristics. So here, I can get a table from them that has income broken down by race and kind of gender, right? So, you know, they have 4 racial categories here. I think, you could argue that this is somewhat simplistic, but this is how we can get the data reported to us. So I can't see these, if I look at these, really there's 108,000 people represented here. I can't get the actual data and look at every single 108,000 different income values. The Census Bureau will only give me an income value based off of group data, right? Grouped by gender and race, okay? So if I'm trying to calculate kind of the average or the mean male income here, well, I have the income value for white males, right, 59,000, or I have the income value for Asian females, right? But this represents way more than just 4 people, right? 4 groups. I've got tons of observations. This income value represents the average income of 73,000 people. And this represents the average income of 6,000 people, right? So I can use these values and then the number of people that were used to calculate those income values as my weights. Now, one nice thing here is I already added up the weights for you, which if we go back, that should just be the value I want for my denominator, right? This sum of the weights, you can kind of think about it in a slightly different way. It would be the number of observations that are in the original data set before it was grouped. Like before they grouped this data for me, there was 108,000 different male incomes, right? I'm only seeing it grouped into 4 different racial categories, okay? So when I add up those weights, that's the total number of observations in that original data set I can't see, right? And that sum of the weights is what I want down here in my denominator. Now, for the numerator, it's just take the weight of each category, multiply it by the value for each category. So 59,000, sorry, I guess if I'm reading left to right, use the weight first, right? 73,000 times 59,000 plus about 12,000 times 38,000 plus 6,000 times 60,000 plus 17,000 times 36,000. Add all those up, right? That gives me my numerator, right? So I can go ahead and do that all on one line, right? And then here I have the sum of my weights, but notice I had already calculated that already. So if I wanted to, I could have just put in that 108,000 there. Okay? And it's as simple as that, right? So one more step, I guess, kind of than what we're doing with the, I guess, two more steps than what we did with the regular mean. We have to add up all the weights, and then we have to, instead of kind of add up the values, we have to add up the values times their weights, okay? So if we do that, we get 53,000. And you know, we'll reproduce this in Excel in just a second, but if you want to try to get some practice of this by hand, here's a number you can use for verification. Oops. Now, if you look at this slide, all I did was put like a box over here. So if you're looking at this on your own and reviewing it, you can just move these out of the way. It was more so for kind of just us going through it. So I'm going to take this data. I'm just going to copy. Actually, I'll copy this whole thing just so it's a little bit easier for us to see. We're going to go into Excel. I'm just going to create a new worksheet. I'm going to make it so it's big so we can see it. And I'm going to just paste, right, that data in there. Okay? So I just copied and pasted the data that we had in Excel. Also, I don't want this value. This is the value that should be the variant or the weighted mean, but I want to show you how we can get that, right? So here I've got the sum of my weights. So just to kind of label this a little bit better as well. So if you're going back, because I'll save this and post it after today's assignment. I won't save it in the COVID file. I'll save it as a new file and just pull these worksheets and put those on Canvas. So what I'm going to do is go through and take the weight times the X value for every single group. So take the weight, multiply by that group's X value, right? Or income value in this example. Right? Now I want to do that for every observation. And then, so B3 and C3, if I copy this down one, it'll become B4 and C4. Well, that's what I want, right? So I can just copy this down. Right? Now that numerator was the sum of those weights times the value. So I'll use that sum function and add these up. Right? Not quite done because that was my numerator and my denominator was my sum of the weights over here. Now, if I hadn't done that ahead of time, so I could click on this cell and that'll give me my weighted mean, right, for female income across the races here. Instead of, if I didn't have that calculated ahead of time, I could have still within that same cell used the sum function and just added up my weights. Right? So you can do this by hand, or we can do it like I just did here in Excel. Part of this class, since we're not taking exams in person, your homeworks and things, you can do this by hand, or you can do this using Excel. Part of your success in this class, if it's getting good at Excel and being able to use it as a calculator instead, that's fine. I would actually suggest that if you can get used to that, right? So we can do kind of this in Excel. We don't have to do it in individual, we don't have to break it down if we don't want to. Sure enough, we get the same value, right? About 32,000. Okay? Yeah. So that's not my numerator. So remember, this is just the sum of my weights. So if we go back to that equation, it's a good question though, right? The numerator is we take each weight for each group and multiply it by that X value and then add them up. The denominator is the sum of just the weights. So when we're looking here, the sum of our weights, that was kind of the number we had in each group, that was that 110,000. The numerator was this, we added up each observation times its weight. Yep. Any other questions on that? Okay with that? So let's do, we'll label that, right? Our weighted mean. Okay? And then we'll do the sum of the weights times the x value. Okay? So once I save this, we'll have a kind of nice, you'll be able to go back and kind of review this. What do I want to, okay. So before we move on, so notice this average is about 32,000. You know, given the data, that's not overly surprising, but you know, we had some lower values here of 28 and 24,000. So why didn't, if we try to take like, you know, think about these as offsetting values, we don't want to think about this like we were the old mean, right? Because even though 39 is what, 7,000 away from 32, and 24,000 is just about 8,000, so they're roughly the same distance from the mean. But if we think about these values, the ones that will have the most influence over that mean are the ones that have the highest weight. So here, the group that has a weight of 75,000 out of the 110, that $34,000 value is going to carry a lot more weight in like pulling that mean in either direction, right? Depending on what the rest of the data looks like. And that value of 39,000 actually has very little relative kind of influence over that weighted mean because its weight's only 6,000 relative to 75,000, okay? So with that idea in mind, if we go down here and we look at this next data set, now I have it broken down by gender and region of the country. I forget exactly what states are in which of these, but it doesn't really matter for the sake of what we're going to do. So I have the values calculated here for you. You could kind of go through these and reproduce these weighted means by hand or try to use Excel to do it, just as some additional practice so you'd have those values to check yourself. But just the general principles, which region here, doesn't matter if we're looking at males or females, should have the most influence over the weighted mean that we calculate. They're not just treated as like 1/4, right? We look at their weights. What would our weights be here? South. Yeah, the South is going to have the highest influence, right? Because pretty clearly the 40,000, 41,000, it has the highest weight, right? We're going to use the number in each one of these regions, the number of people in each one of these regions used to calculate this income value. And the South by far and away has the most people of the 4 regions, okay? In this sample, I don't know if that's true in the United States, but in this sample, it has the highest weight, okay? Which one would have the least? All right, we just look at the lowest weight, and that looks like it's going to be the Northeast, okay? Now, these values don't vary near as much. You know, it's always sad when we look at this data, right? We see like a lot more variation here kind of in, you know, across the genders and across races, we see a lot of variation in this income. But, you know, one thing, you know, just, you know, it's always, I guess, I don't know. It's sad that this still is the way it is. But one thing I do want to point out is, one thing we can also think about is we're calculating the weighted mean. So this still is some measure of where the average male income is and where the average or the middle point of kind of female income is. So here, if we think about male income has a much higher weighted mean, it's kind of just like we talked about last class. It's that distribution would kind of be shifted to the right. We're thinking about that the kind of middle point of male income is going to be higher than that middle point of our female income distribution. Okay? So the same kind of principles apply to the weighted mean as to how we should think about it in terms of how it alters the distribution. Same as a regular mean. Okay. Where are we at on time? Okay, perfect. So if we can calculate weighted means, we can also calculate weighted variances, okay? So the weighted variance is going to look identical to what we were doing before with one exception. Well, I guess kind of two, but you could really technically say one. So we're still going to go through every single observation and subtract the mean and then square that deviation from the mean. So that hasn't changed at all. But now we have to add this additional component. So we said a good way to think about the variance, it's the average deviation from the mean. Well, now if we have group data, when we see a deviation from the mean, it's going to represent a different number of people in the examples that we've been thinking about. So we have to take that deviation squared and weight it by whatever the weights we're using are. Then we add all those up from every observation and divide by the total number of observations. Now here is where it gets tricky. We have to remember, capital N is the total number of observations in that data set we can't see. So another way of thinking about this is also we have to divide by still the sum of our weights. Just like for the weighted mean, we divide by the sum of the weights. We do the same thing for that weighted variance. Okay? So really, it's kind of like combining what we did with the variance, what we did with the weighted mean, kind of mashing the two together. Okay? So I'll show you an example on the slides here, and then we'll look at an example in Excel. Okay? So here, I've got that kind of male income data by race. So all I did was take 59, I went through, took 59,000, subtracted that mean we found of what? 53,000. I then squared it and multiplied it by that group's weight. I wrote all those numbers down. They're huge numbers. I then added them all up and divided by the sum of my weights to get this variance. Okay? I'll show you this in Excel in just a second. But before we go to see how we do this in Excel, we could do the same thing. I calculate the variance for males and the variance for females. To kind of hammer this home, the interpretation of the variance is still very similar if we're calculating the weighted variance. It's still a measure of how much variation from that central point, from that central tendency point or the mean that our data was. So for male income, it has a much higher variance than female income here, right? 15 versus 94, million? Okay. So what is that telling me about female income relative to male income? What could I say? If the variance for male income is higher, variance is a measure of kind of like dispersion or variation in the data. So what this is telling me is that male income varies a lot more, right? Or it kind of can be, it's more likely to be further away from that mean than female income is, okay? So, we think about here, we had a higher male mean for income, so I would shift that distribution to the right. But because it has a higher variance, that's going to flatten that male distribution a lot more relative to that female income distribution. Okay, so it might be, it's much more likely that we see a male income far from its mean, not as likely we see a female income very far from the mean of female income. Any questions on that? So it's the same principles that we were talking about with the variance kind of apply to this weighted. Sorry, did I say that right? The same principles we talked about with the variance apply to the weighted variance as well, okay? All right, so I'll show you how we could calculate these variances pretty easy by hand too. So let's go back here. We got that same data set. I'm just gonna copy this down just to make it a little bit, so we can kind of see a little bit easier. I guess we could add the sum of the weights in here too, huh? All right, so for the variance, our numerator was the sum of those deviations squared times the weight, right? So we're going to take the weight times that deviation from the mean squared, okay? So for the very first observation, we'll take its weight, we'll multiply that by the mean, the observation, the value of that first observation minus the mean. Now we have the weighted mean in the cell up here, right? So I'll select it. And then we have to square that deviation, okay? Now, when I copy this down for the next couple groups, I want to use the new weight for the new group and the new income for that group. So I want these to update, but that weighted mean, I don't want to change. So we'll freeze that cell reference so that it just keeps subtracting the mean for each of these next couple groups, okay? Any questions on that before we keep moving? Make sure there's nothing in the chat. All right. So I'll copy this down. And I've got the weight times the deviation squared for each observation. My numerator was adding all those up. Okay, so I'll use that sum function, add up those values. Okay, that should give me the sum of the weights, whoops, W times X minus the mean squared. All right, and I'll show you a couple things in Excel I'm not sure we've gotten to yet. So if I ever want to like widen the columns, if I go in between the two, and notice how I get like this double-sided, I don't even know what you call this, there's two arrows pointing out from a straight line. If I double left click, it auto fits so that I can kind of see that label I put in there, okay? Now another thing is we see these e's to the +1 ones. Why is there a letter in my number? So this is like scientific format, and all this means is move the decimal point 11 places to the right. If you see e to the -10, it would mean, or a -11, it would mean move the decimal point 11 places to the left, okay? I think if we get this big enough, well, we could format the cells. We could go a number. I don't even want to see the decimals, and now we can kind of get the actual values there if we really wanted to, okay? So we've got that numerator, right? And the denominator was the sum of our weights over here, right? So to get our weighted variance, we could just take that numerator, divide it by our denominator over here, and we get our weighted variance of about 15 million, okay? I think that's what we had in the slides too, so it's good, okay? Any questions over any of that? You want to see some of that again, or we're okay with that? So, doing this by hand, I think it's relatively easy to do this in Excel. You can do it by hand. That's fine if you want to enter all this into a calculator. I just think it's a little bit easier if we can get used to it in Excel. And I broke this down to steps here. You could do a lot of this in the exact same cell, right? So let's say I wanted to add up these values, and then I wanted to divide that by the sum of my weights, right? I could just do that. It's a lot, so I don't have to do all the intermediate steps if I don't want to, but I just want to kind of break it down to kind of make it a little bit easier maybe. Okay? Good with that? Everyone here? All right. So let's go back. Kind of mention a couple things. So we mentioned that we see kind of a higher variation in male income. I put this slide on there as well. If you wanted to, you could kind of do the same thing, copy and paste this data into Excel, play around with trying to be able to calculate it and reproduce these numbers down here. So these should be the weighted variance values you come up with. So this is really just if you want to try to put a little bit of extra time, put into practice. Maybe I'll do an online quiz question after class today that looks something similar to this, that you have to find a weighted mean for a weighted variance. So you have those values to kind of some extra practice with those data sets. So the last thing I wanted to kind of show you, go back here to the paper or the dot cam. So this idea of a weighted mean or a weighted variance, I really want to kind of hammer it home a little bit more. So let's think of a scenario, because I did a lot of examples where we had the number of people, right? That was kind of our weight. Our weights can be very different things, right? Or even I think my one example was the population of a country was my weight. So let's say I've got 2 mutual funds or stocks I've invested in, right? So I look and the one return is something like -2%. The other return is 100%, right? However, it doesn't just matter that those are the returns, because if I think about the amount invested in each one, let's say I put $1 million, right, into one of those stocks. And let's say I put $1 into the other stock, right? Well, if I just ignore the amount invested and I say, well, what's the return of this portfolio? You look at me and you go, okay, you add these up, divide by the number of numbers. So what? Am I doing this right in my head? 98, yeah. So right, 49% is my kind of average. Well, no, that's not the average return of this portfolio, because if you think about it, how much money did I make here from that 100% return? Basically, I doubled my money, so I made $1, right? How much money did I lose here? Well, 1% would be what, $10,000, so I lost $20,000. So clearly, like, the average return, I lost, what, 20,000 minus one, or negative 20,000 plus $1. So I lost $19,999, right? My return wasn't positive 49%. So the way that you could calculate the average return of this portfolio is these returns don't represent the number of people now, but they represent the proportion of my total portfolio that was invested in this one stock or this one mutual fund, right? So I would go 1 million times that negative 2% return, plus that $1 times the 100% return, divide by the sum of my weights, right? And I could get my weighted mean. I can't do that math completely in my head. I could maybe get close if I tried, but, All right. So, I think this is a really good example where it's like, yeah, you can't say the return of this portfolio is positive 49% because you're ignoring the fact that this return, this observation, represented a much larger proportion of the portfolio. Right? So it's just a slightly different example, that not kind of this where your weights are free, the number of people. Our weights could be something like the amount invested into those different categories or different assets. Okay? Also, these classes run together a little bit, but whenever I'm using this, if I get like this or something, make sure you let me know if it gets way too far off, because I'm writing on an angle and trying to look at it, and I don't want it to ever end up being where you can't read it, okay? Other than that, I think that should take care of it for us today. That Connect assignment's out there. I'll get that first Excel up there. Shouldn't be too bad, I think, if you kind of get started on it early. Look at that COVID data complete file, right? So there's a completed version that's up there on Canvas as well as you're working on that first Excel assignment. That'll be a really good template, what we did with the COVID data by state in class. It'll be a really good template for that first Excel assignment, okay? Other than that, if you have any questions, feel free to reach out, email me. Group 2 will be the ones that are assigned to show up Wednesday. We'll have plenty of extra seats today, so I'm guessing if any of you guys want to show up in person Wednesday, there'll probably be enough room for you, okay? All right, we'll see you guys Wednesday.